Hi everyone, today we're going to talk about modeling sinusoidal function in real-world problems. So we have some situations in real world that follow sinusoidal functions actually. One of the most famous ones is Ferris wheel problem. So when you get into a Ferris wheel, your height from the ground actually follows a sinusoidal function. I'm going to show that here to you. So in this shape, we have a Ferris wheel, and as you are moving around, like taking the ride on the Ferris wheel, your height is going to go up and down and up and down. So because your movement is kind of being repeated in a constant period of time, this is following a sinusoidal function. So I can show it here. As I'm moving this cursor, the time is going to increase, and your height is going to be shown here. And the function, the graph of your function will be graphed here. So as you see, as I'm moving forward, the height is changing, and also the graph is going to be shown here. Because I'm going up and down and up and down, so the graph is looking like a sinusoidal function. That's why we say the height on a Ferris wheel actually follows a sinusoidal function. So let's go here to the problem. So in this problem, it says you're standing in a line to ride the Texas Star Ferris wheel at the State Fair of Texas. As you're waiting, you notice that while riding the Texas Star, a person's distance from the ground varies sinusoidally with the time. You read in your official guide to the State Fair of Texas that the Texas Star has a diameter of 220 feet. So I'm going to underline this part. And you notice that it takes 82 seconds for the Ferris wheel to make one revolution. So this is important. It takes one revolution, 82 seconds. As you approach the loading dock, you estimate that the passengers load the cars 8 feet from the ground. It is finally your time to load the Ferris wheel, but once you are on, they continue to load several other cars. When the Texas Star is fully loaded and begins to continuously turn, you start your stopwatch. It takes you 50 seconds to reach the top. So here I'm going to show a picture of the situation. Let's say this is the Ferris wheel. The diameter of this Ferris wheel is 212. And let's say this is where you're loading people. It's 8 feet above the ground. So this distance is almost 8 feet above the ground. So the first question is asking, how high is the top of the Texas Star? The highest point is here. So the highest point is 220 plus 8, which is 212 plus 8, which is 220 feet. So this is the highest point. And of course, the lowest point is here at 8. What time will your stopwatch read when you get back to the bottom? So as you get into the car, it's going to take 50 seconds to reach to the top. Why? Because they're loading other people. So it's going to take 50 seconds to reach to the top. And then after that, you're going to move down to reach to the beginning point. Like the other half is because they are not loading any other people, they're moving with their normal speed, which is 82 seconds for one revolution. And this is half of the circle or half of the revolution. So it's going to take 41 seconds. So to reach to the low point here, it's going to take 50 plus 41, which is 91 seconds. The next question is asking how much elapsed time will it take to reach to the top of the Texas Star for the second time. So we moved like here to the top, and then we went back to the start point, and then we're going to go another half circle to reach to the highest point again. We know that another half circle, because we're moving by the normal speed, which is 82 seconds for the full circle. So half of the circle is going to take 41 seconds. So the other half is 41 seconds, and it already took 91 seconds to reach to this point. So it's going to be 91 plus 41, which is 132. seconds to reach to the highest point again. Now we want to graph the sinusoidal axis. We know that the graph of the function is showing the height versus time. So the y value, the y-axis is height and the x-axis is the time. And we know that the highest point on this first rule is 220. We just figured this out. And the lowest point is 8. We know that we're going to have a sinusoidal function. So we need a sinusoidal axis here, which is the midpoint of the highest and the lowest point, somewhere like here. To find the exact value of this point, we just need to take the highest point and add it to the lowest point and divide that by 2, which will be 228 by 2, which is 114. So y equal to 114 is the sinusoidal axis here. Then let's go back to the problem over here. It says it takes 50 seconds to reach to the top point. So if I start my stopwatch here at time equal to 0, it takes 50 seconds to reach to the highest point, which is here at 220. So this is the first point that I already have here. Then we know that the period of this function is 82. Why? Because here it says it takes 82 seconds for one revolution. That means one period. And we know that on the graph, the distance between two high points is one period. So let's say this is one high point. The next high point is something like this, and it takes 82 seconds or one period to reach to the next high point. So this point here is my next high point. From 50 plus 82, which is 132. So this point is 132, which is my next high point. I know that I have a sinusoidal function, and I know in a sinusoidal function between two high points, right in the middle between those two, we have a low point. So the midpoint between these two, let's say somewhere like here, which is 91. 132 plus 50 divided by 2 is 91. At this point, I have a low point, which is at 8. Then I know that in between a high and a low point, I have a midpoint. So in midpoint here, I have a middle point. And another midpoint here, I have a middle point. So this will be the graph of my function. So as long as I have two high points, it's easy to graph the rest of it. Just the middle of that, I have a low point, and in between them, we have the middle point. So this is the graph of my function. Then to write the equation of this graph, we know that the general form is y equal to c plus a sine or cosine of b theta minus d. So we're going to start finding all these values. C is the vertical shift or the sinusoidal axis, which is here at 114. So this is 114. And then A is the amplitude. Amplitude is the distance between the highest point and the sinusoidal function. This distance is 1.6. 220 minus 114 is 106. So this is the amplitude. And because the graph is starting with a high point, I know that I'm writing a cosine function, so I'm going to write cosine. To find the b value, we know that b value is the period divided by, is actually 2 pi divided by the period. We're working with radian, that's why we take 2 pi. Divide by period, which is 82. So 2 pi divided by 82, which will be pi over 41. So this is the b value. I'm going to write that here. And then theta minus d is the horizontal shift, which is here at 50. The horizontal shift moved 50 to the right. So minus 50. So this is the equation of the function. Let's go to the questions over here. We need to predict the height above the ground when t is 15. So basically, if time is 15, that's the x value, and we're looking for the height, which is the y value. To find this, I'm going to use my calculator. So we go to the calculator, we enter the equation into the calculator using y equal, you enter that into y1, and then you graph this. Make sure you have the proper window. On the graph that we just graphed here, we see that the maximum x is at least 132 and maximum y is 220. So to graph the function here, we need to have the proper window. I define the window x from -2 to, let's say, 150, and the y value -5 to 250. So if I graph the function, I'm going to see something like this. So I can see almost all of the graph. Now, to find the y value when t is 15, I go second trace and the first one value. So when x is 15, actually my time is 15, what is my y value? Enter, is 19 point something. So the height at this point when time is 15 is 19.006 feet. So this is the height. And as you see here, this is the point that I was looking for, and I'm going up actually on the first wheel. We're going up because the height is increasing, so we're going up here. The next problem, the next question says when time is 17 seconds, then what is the height? So we're going to do the same thing here. Second trace value, this time for x we're going to enter 75, and it's 78.17. So height is 78.17 feet. Next one, when time is 5 minutes. Notice that so far we were working with seconds, but now we're working with minutes. So we need to change this to seconds. 5 times 60 is 300 seconds. So on my calculator, I'm going to go second trace and enter 300. As you see, I'm getting an error. The reason is that my window was defined until just maximum x was 150, and we're looking for 300. So we need to change the window to be able to see the value we're looking for. Let's just enter 350, and now I go second trace value. This time as I enter 300, I can see the y value, which is 215. So height is 215 point something, which was 06. Okay. Next one says, how high were you when you started your stopwatch? When I started my stopwatch, actually the time was 0. So it's right here. When time was 0, what was my y value at that point? So again, I'm going to do the same thing. Second trace value. This time for x, I'm going to enter 0. So what was my height when I started my time? It was 32. So the height was 32 point something, 0.2 feet. Were we moving up or down at that point? We were moving down because the height is decreasing. The next question is asking, what is the value of t the second time you're 100 feet off the ground? Like if your height is 100 feet, which is the y value actually, what is your time? Or actually, what is your x? So let's go to the graph. To find this, I'm going to define another equation. y2 is equal to 100. So if I graph the function, you see we have two graphs. One is the curve, which is the cosine function, and the red line is y equal to 100. The intersects of these two functions are actually where our height is 100. As you see, we have multiple intersects here because we're going up and down in this Ferris wheel. So we have multiple points that our height is 100. It's asking for the second time that your height is 100. So this is the first time and this one is the second time. I don't care about this one because this is before the y-axis, like on the left side. That means the time was negative, which doesn't make sense. So I don't care about this side. I'm just gonna work on the right side. So the first time height is 100 is here, the second time is here. So I need to find the intersect at this point. So I go second, trace, and number 5, which is intersect. Then first curve, just enter. Your calculator automatically is going to move on the curve. The second curve is going to go there, enter, and then you need to go stay on top of the second point. So move the cursor to the intersect point, which is here, and it's 72.22. So when time is 72.22 seconds, the height is equal to 100 feet. The next one says, what is the value of t the fifth time you're at 175 feet off the ground? So again, almost the same thing. I'm going to define another y, which is 175 here. And then as I graph the function, I go to 5, intersect. So the blue one is the original function and the red line is the y equal to 175. The intersects are the heights, which are at 175. Now we're looking for the fifth time. 1, 2, 3, 4, 5. So we're looking for this point. So let's start. First curve, just enter. Second curve, again enter. Then we need to go stay on top of this point. The fifth time we're at the height of 175, which is almost here. Enter, and it's 201.5. So when time is 201.5 seconds, the height is 175 feet. So this is how you need to solve these kind of real-world problems. The first thing and the most important part is to read the question carefully, underline the important parts, and try to imagine the situation. Use a shape to draw the situation and understand what is happening, and then from there you can graph your function and solve all the questions. I hope that this was helpful, and have a great day.